Hey everyone, in this video we're going to learn about interval notation, which is a method of writing subsets of the real numbers by using parentheses and brackets. Essentially, this is another way to represent an inequality. In the definition, when they're talking about subsets of the real numbers, think about graphing the solution set of an inequality on the real number line. What we shade is a subset of the real numbers, and we've shaded an interval on the number line, and that's where we get the phrase interval notation. When using interval notation, parentheses represent solutions greater than or less than the number. So if an inequality has a greater than or less than sign, it will be replaced by a parentheses in interval notation. They are also used for positive and negative infinity, so this is a bit different. We don't see positive or negative infinity when we write inequalities, but we're going to see them when we write interval notation, and we'll see why in our first example. Now, the reason they fall under parentheses is infinity is a concept. We can never truly be equal to an infinite value. So because of that, the parentheses is going to be the symbol that's associated with either positive or negative infinity to represent that idea that we can't ever truly be equal to either. Brackets, on the other hand, represent solutions that are greater than or equal to or less than or equal to the number. So if we have a greater than or equal to or a less than or equal to sign in an inequality, it will be replaced by a bracket. Now, there's a lot of similarity between inequalities and interval notation, but there's also a few differences. So let's compare the two side by side. Our first example, write the given solution sets using both inequalities and interval notation. Our first solution set, we have from 1 to 4, where 1 is an open point and 4 is a closed point. So let's start with what we're more comfortable with, which is the inequality. So we're going to write this as 1 is less than x, which is less than or equal to 4. Now in interval notation, we're going to represent the interval from left to right, from lower values to higher values, and that's an important idea. So starting on the left, the interval starts at 1 and it goes to 4. Now 1 is an open point, so we don't have equality, right? 1 is less than x. So we're going to put a parentheses on the left of the interval. And then 4, we do have equality, right? Less than or equal to. So we're going to put a bracket on the right. So right now I want you to look at the inequality and look at the interval notation. Some of the big differences, first, is there's no variable in interval notation, right, where there is when we write an inequality. Next is how we order things. Right, in inequality, it's 1 is less than x, which is less than or equal to 4. Interval notation is parentheses 1 comma 4 bracket. Okay, so the signs, the parentheses and brackets, go outside, the interval goes inside of those. Whereas in an inequality, the signs are inside the values that define the interval. Okay, so these are a few differences. Now we can also see why use interval notation. Well, it's a more compact way to represent the same solution set. And if we're writing a bunch of answers, it's just going to be more efficient for us to represent our answers with interval notation opposed to an inequality. So our next solution set, on the number line, we have all values shaded that are less than or equal to -2. So as an inequality, x is less than or equal to -2. Now in interval notation, we need to go from the left of the interval to the right of the interval, right? From the lower values to the higher values. But this arrow indicates that the solution set's going to go on infinitely to -infinity. So that's where we're going to start our interval. Our interval is going to go from -infinity to -2. Now remember, we can't ever really be equal to -infinity. So we're going to use a parentheses on the left side of the interval. And at -2, we have equality. So we're going to use a bracket. So here, this is a good example where an inequality does not have the -infinity in it, but our interval does, right? Because we need to define both sides, technically, of the interval. In this case, the solution set goes to -infinity, so that's where we're going to start our interval. So now let's look at a bunch of examples to get more comfortable using interval notation. Rewrite the following inequalities in interval notation. -6 is less than x, which is less than 1. So the interval, -6 to 1, we have less than, so no equality, so we'll have parentheses on both sides of the interval. 3 is less than or equal to x, which is less than or equal to 4. So our interval is from 3 to 4, and we have equality, so brackets on both sides of the interval. 12 is less than x, which is less than or equal to 21. So our interval goes from 12 to 21. Less than, right, 12 is less than x, so no equality. Start with a parentheses. Then x is less than or equal to 21, so we do have equality. We'll end with a bracket. Okay, so those are 3 nice examples that we can compare inequalities to their interval notation. Now we have x is less than or equal to -15. So if we think about this solution set, right, we put a closed point at -15 and shade all the values that are less than -15, all the way to -infinity. So our interval is going to be from -infinity to -15. And remember, it can't ever be equal to an infinite value, so we start with the parentheses on the left. And then x is less than or equal to -15, so we have a bracket on the right of our interval. X is greater than 2. Right, so think about our solution set. And this one, I'll actually graph it as a strategy to help us with our interval notation. And something I would encourage you to do if you're struggling figuring out what your interval looks like. So if we were to graph this, and we'd have an open point at 2, and we'd shade to the right. So defining our interval, the interval goes from 2 to infinity. Don't have equality at 2, so we start with the parentheses, and we're never going to be equal to an infinite value, so the right side ends with a parentheses. So here we see 2 examples with -infinity and +infinity in the intervals. And now we have a compound inequality, so x is less than 1, or x is greater than or equal to 7. And again, I'll just make a quick graph of the solution set and use that as a tool to help us figure out what the interval notation would be. So x is less than 1, open point, shade to the left. Right, all the values that are less than 1. X is greater than or equal to 7, so close point, all the values that are greater than 7, 8, 9, 10 are to the right. So now we're going to have to define 2 separate intervals. So the first interval goes from -infinity to 1, parentheses, and we don't have equality at 1, so parentheses. And then the second interval is going to go from 7 to infinity. At 7 we have equality, so bracket on the left, parentheses on the right. In interval notation we don't write or, it's going to be a U symbol connecting the 2 intervals. So in interval notation, that symbol represents or. Okay, so you can make a note to yourself that this is how we're going to want to connect intervals. Okay, so now let's go in the other direction. Rewrite the following intervals as inequalities. So we have bracket 0, comma 3, bracket. So as an inequality, this is 0 is less than or equal to x, which is less than or equal to 3. Right, x is any value between 0 and 3, and we have equality because of the brackets. Now we have parentheses, -2, comma 2 parentheses. So our inequality is going to be -2 is less than x, which is less than 2. Again, x is between -2 and 2. No equality because we have parentheses. Bracket -7 to -4 parentheses. So our inequality is going to be -7 is less than or equal to x, which is less than -4. Next interval, parentheses, -infinity, comma -1 bracket. So that interval is x is less than or equal to -1. Now technically, could we write -infinity is less than x, less than or equal to -1? We could, but that's not correct notation, so we leave off that left part here. Right? When we have -infinity or +infinity in the interval, it shouldn't show up in our inequality. Next, we have parentheses 11, comma infinity parentheses. So this is going to be x is greater than 11. Now again, we can use the same strategy as before. If we're not sure what the inequality looks like, sketch the interval on the number line, right? So parentheses 11, so open point, and we're shading towards positive infinity, and use that to figure out what the inequality is. And now we have a compound interval notation. So our first interval, parentheses -10, comma -8 bracket, so it's going to be -10 is less than x, which is less than or equal to -8. The u becomes an or, then parentheses 1 comma infinity, parentheses, is going to be x is greater than 1. Now if it makes more sense for you to write this as 1 is less than x to stay consistent with how we've done the other intervals, that's fine. We should understand that x is greater than 1 and 1 is less than x are the same inequality. Now our next example, graph the solution set and rewrite in interval notation. So we've seen x is not equal to 8 before. So graphing the solution set, we put 8 on the number line, open point at 8, and we shade every value that's not 8. So in interval notation, we're going to first deal with this interval. So that's going to go from -infinity to +8. So -infinity, parentheses, and then not equal to 8, so parentheses, union or, and then 8 to infinity. Okay, so this is called a union symbol. I don't know if I mentioned that earlier. And this helps us also understand how we would rewrite this as a compound inequality, right? We would write x is less than 8 or x is greater than 8. So this is the same thing, just in interval notation. Now going the other direction, graph the solution set and rewrite as an inequality. So we have interval notation. So we'll set up a number line. So we have 5, 6, and 13 as our important values. So parentheses, -infinity, comma 5 parentheses. So we start shading at -infinity till we get to 5, and we have an open point due to the parentheses. And then we start shading at 6 with a closed point all the way till we get to 13 and end with a closed point. So as an inequality, we have x is less than 5 or 6 is less than or equal to x, which is less than or equal to 13. So again, we're trying to see how what we're familiar with inequalities looks like in interval notation. And a good tool to kind of get us there is graph out the solution set, even if they don't ask for it, right? Like I showed you earlier. Graph the solution set or the interval and use that to figure out what your interval or your inequality should be. Our last example combines both. If x is an integer in the interval bracket 2, 10 bracket, state all integers that satisfy the inequality below. 3 times the quantity x minus 4 plus 2x is less than 5x minus the quantity 2x plus 3. So before we look at the interval, let's first solve the inequality. So we'll start by distributing the 3 and the -1. So we have 3x minus 12 plus 2x is less than 5x minus 2x minus 3. Now we can combine like terms on both sides. So we have 5x minus 12 is less than 3x minus 3. Subtract 3x from both sides. So we have 2x minus 12 is less than -3. We can add 12 to both sides. So we have 2x is less than 9. And then we finally divide both sides by 2. So x is less than 9 over 2. So now going back up, and I'll just rewrite this over here, x is less than 9/2. So then they gave us an interval from 2 to 10, and they said if x is an integer value in this interval, so between 2 and 10, if we wrote that as an inequality, 2 is less than or equal to x, which is less than or equal to 10, we have to figure out integers that satisfy both of these inequalities. Right, so we have a couple of ways. We can just think straight out. So x is less than 9/2, so that's 4.5 in decimal form. So what integers fall into this compound inequality that are less than 4.5? Well, we'd have 2, we'd have 3, and we'd have 4. Okay. If you find it helpful, you can list all of the integers that satisfy this compound inequality, and then take each of those integers and see if they satisfy this inequality one by one, and only take the ones that work. So you'd have 2, 3, 4. Or you can graph both of these on a number line and see where the solution sets overlap and see what integers are in that overlapping section. So a couple different ways that you can come up with the answer, but you want to come up with the answer 2, 3, and 4. Right? 5 is too big, 6, 7, 8, 9, and 10 would also be too big. Right? So there's interval notation. Compare it to inequalities, right? See what's familiar, see what's different, and use those to help us when we're asked to state an answer or a solution set in interval notation, or asked to take something in interval notation and rewrite it as an inequality. And again, the other strategy, don't be afraid to graph the solution set, whether it's in interval notation or in inequality, and use the graph to help you. Right? So now go practice so that you feel confident with interval notation.